So trig ratios. Now in radians, we're supposed to find tan of negative 7 pi over 3. And you might be tempted to just put that in your calculator. But they say determine the exact value, which means don't put it in your calculator. It means muscle your way through it and figure it out. So what we're going to do is put it on the unit circle. And in order to do that, we want to simplify negative 7 pi over 3 because that's ugly. 6 pi over 3, 6 over 3 is 2 pi. That's a whole circle, so we could just get rid of that one. If it's more than 2, 7 divided by 3 is more than 2, then we can take one full rotation out and just simplify it. So the first thing we want to do is decide what's left after we do that. So I've got negative 7 pi over 3, and I'm going to get rid of 6 over 3. And you could write 6 pi, but it's just basically, we're just looking at this part. So let's just get rid of this for now. We're just going to look at these ratios. So negative 7, we get rid of 6. That means we've still got negative 1 over 3. And now we can put the pi back there. So it's basically pi over 3 that we're looking at. And we know that we're going in the negative direction. Now, this whole thing is pi. So we could call it negative pi if we wanted to because we're going back this way, but it's just the distance is pi. So pi over 3 or negative 1/3 pi is going to be 1/3 of that. So if I cut this into thirds, that would be 1/3, 1/3, 1/3. Then what I'm looking at is right here. So I'll take that out now just to keep it simple. And this would be pi over 3. Well, if we think about it in terms of degrees, just for a second, because we're getting used to this whole thing, then that's minus 60 degrees, isn't it? Because it's 2/3 of the way past 90 degrees. And you can look at your diagram with the circle on it that I uploaded for this chapter, and you can see where that fits. So if we were just looking at this as a reference angle, then we could equate it, whoops, that's not quite right. We could equate it to 60 degrees as a reference angle. And now I'm not encouraging you to continue to keep thinking in degrees, but when we first start trading over to radians, I think it's not an unwise idea to do that. So what we would want to do is remember that, and you should have this marked down on your cheat sheet, but we would remember that we have this triangle, and if it's 60 degrees and this is 1, then this side is a half, and this side is √3 over 2, because those are just, whoops, those are just standard units of measure that we've previously established. So if that's the case, then this point would be √3 over 2 and 1/2, and therefore this point would be the same but with a negative y value. So our point down here should be negative √3 over 2 and 1/2 because we have simply flipped this over the x-axis. Now, why is that relevant? Well, tan is simply y over x. So if we have the y and the x, then we can find the exact value for tan. So I'm just going to switch colors here to make this stand out a bit more. Tan of the angle, which would be this, is equal to y over x, which in this case is negative √3 over 2, and I'm going to write it this way so I'm not stacking fractions, divided by 1/2, which would give me negative √3 over 2 times 2 over 1. I would cancel those out, and therefore the exact value for tan of this angle would be negative √2.